Hi and welcome. I am Mats Hjelte, your friendly doors magician from Syntell, and I will guide you through a series of videos that present our DEXVariants tool. DEXVariants is a doors add-on that helps you handle reuse and variability with a smart versioning approach that extends to doors baselining. This first video of the series introduces the tool and its intended usage. What could be more efficient in systems development than to just reuse what has already been developed? DEXVariants enables reuse. A reuse that is not just limited to general low-level components, but to entire system models containing requirements, architecture descriptions, verification tests, traceability, code, and so on. The idea is to define a generic system model, a reusable asset from which different artifacts can be reused. Multiple variant systems will then reuse these assets in a way that fits their individual purpose. Depending on situation, a variant system can be many different things. The first thing that comes to mind is a deliverable system for a given customer. But you could also, for example, handle two separate versions of the same system as variants. If you, for example, do iterative development with overlapping increments. In general, a variant system should be viewed just as a branch of the generic reusable system. The purpose of the branch is more or less up to you. This kind of large-scale reuse is commonly referred to as a product line approach. For this kind of reuse to work, there needs to be great similarities between the variant systems. There must also be a strategy for handling the differences between the variant systems. For an efficient reuse, we should try to keep the product line together to avoid unnecessary deviations between variant systems. The reuse should start at the requirements level. If development is based on a common base of reusable requirements, similarities will increase and it will be easier to avoid deviations. We also need a good configuration management that allows a given artifact or a version of an artifact to be reused in more than one context. We need a structure that allows us to know exactly what is included in each release. As the need arises to create new variant systems, reusable on-the-shelf assets will provide a fast way to get specifications and development up and running. Also, new requirements and related artifacts will typically need to be added for the variant system. This means extending the product line with new features that will then be available for other variant systems. According to the Software Engineering Institute, a software product line is a set of software-intensive systems that share a common managed set of features satisfying the specific needs of a particular market segment or mission, and that are developed from a common set of core assets in a prescribed way. I suggest you follow the link and read more at their website. Reuse is, of course, not just limited to software or software-intensive systems. Let's just define product lines as a set of similar systems, a family of systems, where similarities in requirements and structure enable a large-scale reuse. The product line approach promises some really interesting benefits. By means of reuse, some really large-scale productivity gains can be achieved. According to the Software Engineering Institute, productivity can rise up to 10 times. What we talk about here is not just reuse of smaller software components, for example, but of entire subsystems, of requirements, of test cases, and so on. For this to work, enough commonality needs to exist between systems. Also, a good modularity will be needed in the generic system model from which the variant systems are created. Reuse starts at the requirements level, which means that it will be possible to keep the system family together and avoid unnecessary deviations. Not surprisingly, the time to market will decrease. Reusing existing components should of course be faster than creating new ones. Product quality will typically also benefit, since new systems will be built based on proven components that have already been used in previous systems. And with this comes better customer satisfaction. The benefits also cover other factors, such as product risk, market agility, efficient use of human resources, ability to effect mass customization, maintain market presence, and sustain growth. To get the benefits of the product line approach, there are some challenges that you need to overcome. The fact that different artifacts need to be reusable in different contexts creates a more complex system model. Doors right out of the box is not really equipped to handle this. We need a better configuration management. A configuration management that supports reuse. There are also other challenges, such as the need for a different development organization. But we will not discuss this here, since we are more interested in the structuring of the system model. One of the most crucial aspects to handle is variability. Your product line will typically provide a set of generic specifications to reuse from. Reusable requirements, test cases, design information, and so on. The specifications of a certain variant system would then include a subset of this reusable data. Some kind of selection mechanism will be needed to make this possible. The way you do this selection is quite important. Without good tool support, you would probably solve your variant problem by making copies of the generic specification. Copies that you would then edit to suit the needs of your variant system. This copy and own approach has its serious drawbacks. The copies will take on their own life. They become disconnected from the generic specification. And as a result, the system model of your product will start to deviate. You could say that the entropy of your system model increases. You tend to lose track of the changes you do in your different variants. And when there is a need to harmonize changes between variants, this results in a lot of manual work. Copying of objects also complicates the reuse of links. You will need to recreate links between your copied objects. A better strategy is to reuse the objects in place with an attribute tagging that selects objects for different variants. We call this the pick list approach, and this is also the approach that is used by DEXVariants. Instead of the common one module, one document approach, the module now becomes a reusable database from which objects can be selected by means of pick lists representing different documents. Each module can contain many such pick lists, and new pick lists can be added as the need arises to handle new variant branches. The picture here shows a typical traceability structure for a system. In this case, we only have a variant system A in our system model. To the left, you can see a doors module containing stakeholder requirements that came from the customer. These stakeholder requirements are then met by a set of system requirements in our generic system requirements module. Here a pick list for system A selects requirements S1, S2 and S4. And we also have traceability back to the corresponding stakeholder requirements. In a similar way, a pick list for system A in our generic test specification selects the corresponding test cases T1, T2, and T4. And finally, there are test results linked to each test case. Now let's introduce a new variant system B. B has a separate set of stakeholder requirements. We can assume that these came directly from the customer. Our next step will now be to try to match these stakeholder requirements to our existing reusable requirements, those that are currently in our product line. Stakeholder requirement B1 can be matched to S1 and S2, or at least almost. To get a good match for S1, we need to create a new version S1 prime of the requirement to accommodate some necessary changes. Note that S2 is reused as is by both A and B. For B2, we had to create a new requirement S3. This means adding new capabilities to the product line. B3 was properly met by S4, which means that S4 can be used by B as well as by A. When reusing a requirement for our variant, it is also natural to follow the link and reuse corresponding test cases. This also means reusing traceability links between reused requirements and test cases. For example, take a look at requirement S2, which already existed in A. The natural thing is now to also include T2 in pick list for B in the test specification module. As a result, you will also reuse the link between T2 and S2 in the context of this variant B. Note that objects and links are reused without copying. DEXVariants uses this pick list approach to reuse objects in place. There is no copying of objects. DEXVariants also adds versioning at the object level. For a given logical object, such as a requirement or a test case, multiple versions can coexist in the current version of the module. Each such object version is represented by a separate doors object. A trigger-enforced rule makes sure that a given pick list does not select more than one version of a given logical object. A version tagging also shows in which variant baselines the object version is included. This tagging is automatically added when a variant specification is baselined. Finally, frozen objects, that is, objects that are part of a frozen variant baseline, are protected from update by means of a trigger. The best way of illustrating this is perhaps to take a look at the doors module that has been set up with DEXVariants. Here we can see a set of requirements. Let's look at this one, for example. The flexboat shall have a mooring loop in the bow. You can see that what we show here is a view for a certain variant. And this attribute, TechnoSelect, is the pick list for this variant that's called Techno. We also have this Techno version attribute that is automatically updated, that shows in which variant baselines of this Techno variant that these objects are included. The filter of this view is TechnoSelect equals true, which means that this view shows the objects that will be included in the next version of this variant, this Techno variant. And also, since all the objects we can see here are included in a previous release, many previous releases actually, they are frozen. They cannot be updated. So let's try to update an object, see what happens. This shall have two, sorry. I want to have two mooring loops in the bow. When I do this change, it will be intercepted by a trigger that tells me that I'm trying to update the frozen object. And if I want to do that, I will need to confirm. So I select, okay, I want to link a couple links as well. I press OK here. And what happens then is that the new object is created. This object has the same identity as the previous one. The selection moved from the old one to the new one. The new object is editable, and it's not part of any version, any techno version yet. And you can see here also that the change I did was included in the new object instead, the new version here, instead of in the previous one. Let's save this. If I refresh the filter here, I will only see this new object. But I could, of course, apply another filter here, like techno version includes 3.3, the last. Let's see what happens. Okay, then I get the old one instead. So you can always use filtering to extract the version you're interested in. Now let's create a variant baseline. Let's see. DEXVariants create new variant baseline. Let's create the new version 3.4 here. Yeah. Okay, what happens now is that the baseline is created, but that's not the only thing. Mooring. You can see now that this object we added, this new version, it's actually frozen also. It gets frozen, it gets tagged with this new version, and it and then the baseline is created. Let's turn off this filter. Now we can see both the old and the new one. Here's the old one, used in previous versions. Here's the new one. Let's say I want to move back to the old version. I could do that by simply clicking here. I select the old one instead. But since you only may select one version, I get this warning, and I confirm, and then you can see that this new one was deselected. But I guess I would like to have the new one instead. So let's go back to that. Okay. And this is just one of the variants in this module. There could be other variants as well, like there's, for example, a leisure variant that has its own view here. Let's have a look at that one. And you can see here, it uses this old version of the requirement, not our new one. And it has its own set of versions. This leisure variant has its own set of versions, independent of the techno variant. If we look at the door baseline here, you can see that there are, each time I create a variant baseline, a new door baseline is created. But as I said, first this version tagging is created and objects are also frozen. Let's wrap things up by looking at this concept map. The map illustrates what you have already seen, but it also introduces the DEXVariants functions for feature modeling that we have not yet talked about. At the heart of DEXVariants are generic specification modules containing reusable objects. A reusable object may come in more than one version. Each such object is a version of a logical object. For example, a given requirement can exist in multiple versions represented by different doors objects. New and old versions are kept in the current version of the module. They are not just tucked away in the module baseline. In the same module, one or many variant specifications can exist. Each such variant specification is defined by a pick list that selects reusable objects. Variant specifications can be frozen in variant baselines. A variant baseline is stored as a doors baseline. But before the baseline is stored, all objects selected by the pick list are given a version tagging, marking them as included in the new variant baseline. Also, the objects are tagged as frozen, and frozen objects are protected from update by means of a trigger. A result of the pick list approach is that each object becomes a variation point. This may not always be desirable. DEXVariants therefore includes an add-on for feature modeling. Feature modeling allows you to model the constraints of the selection. The idea is to control the selection in variant specifications automatically based on the selection of features done in the feature model. A feature model contains a set of features and is stored in a separate doors module. Features have mutual constraints. For example, a given feature may require or exclude another feature. The reusable objects in the generic specification are logically connected to one or more features. This is what makes it possible to control the selection of these reusable objects based on the feature selection. In the same module, one or many feature configurations are stored that represent the configurations for different variant systems. Each such feature configuration is defined by a pick list that selects a set of features. And these features must be selected according to the rules of the feature module. They must not invalidate the constraints. Since reusable objects have a connection to the controlling features, The selection of features in the feature configuration can now directly control the selection in variant specifications. This is done automatically by updating the pick lists for these variant specifications. At this point, this is all I will say about feature modeling. There is a separate video on the feature modeling tools of DEXVariants. So if you're interested in the feature modeling, I suggest you look at this video. Thank you for your interest so far. If you're interested in this tool, I suggest you go to www.syntell.se, and there you can find all the contact information you need. Thank you very much.